In this video, we're going to look at working out the mean and standard deviation of group data. So whenever you've got group data like so, you would have to work out the midpoint, and you should be well aware of how to do that from GCSE. So what we need to do is, first of all, write down the formula for both the mean and standard deviation. So what is that? So what we get is the following. So to work out the mean, but in our case, because it's group data, we need to do the sum of f times x. So in our case, we've got f, the frequency here, we've got x, which is the midpoint, and we can get these values from a calculator. So how do we do that? So whenever you've got group data, you tell the calculator you're going to put in the midpoint for the data values. So, and we need to have a frequency column. So to get the frequency column, you press Shift, Menu, and you're going to go down to Statistics, which is option number 3, and you're going to turn the frequency on by option 1. So now what happens is you're going to go to Menu, and you're going to choose the Stats option, which is number 6. And what you're going to do is choose one variable, which is option number 1. So now what you're going to do is type in all the midpoints, and you must do this for group data. So we get 4.5, we get 7.5, we get 9.5, we get 13, and we get 18. But what we notice on our calculator, it's assumed that the frequency is 1, which is incorrect. The frequencies are in the table, and we need to write those corresponding frequencies into our table. So for 4.5, we get 38, followed by 25, followed by 18, followed by 12, followed by 7. And now what we're going to do is press AC, press the option button, and then we're going to press one variable calculation, which is option 2, and then we get all these values. So the sum of x on this calculator is actually the sum of fx. So what we're going to get is the sum of fx is 811.5. So I'm going to write that down. So the sum of fx was 811, I believe it's 0.5. And then we also need to write down the sum of fx squared. Now they've already given that to us, and we can check that on our calculator, and that is indeed 8096.25 or 8096.25. And now you know where the sum of fx squared has come from. So the calculator gives you these values, and they've told us that the mean is approximately 8.1, and the sum of f is n, which is going to be 100. So I'm going to write n equals 100. Now, before we proceed, I just want to give you a caveat, and that is that even though the calculator gives you quartiles, these are incorrect. The calculator does not use linear interpolation, as I've shown you in class and in previous videos. So please refrain from writing those quartiles down. They're incorrect. You must use linear interpolation when you've got group data. Okay, so now, how do we do this? So we can say, all right, okay, so let's go back to our menu, and then we can write down what the mean is. Well, the mean is 811.5 divided by the number of values, which is 100. So we're going to get 8.115, which is approximately 8.1. Now, when you calculate the standard deviation, you must use the true value. You cannot use a rounded value, or as your answer will be inaccurate. So let's work out the standard deviation. Well, what's the formula for the standard deviation? Because it's group data, it's going to be sigma, is going to be the square root of the sum of fx squared divided by the total number of values, that's the sum of f, minus the mean squared. That's the formula for the standard deviation. So we know what the sum of fx squared is. It's 8096.25. So let's substitute that in. So we've got that sigma is going to be 8096.25 over the sum of values, which is 100, minus what we wrote down earlier, the true value for the mean, which was 811.5 over 100. All squared. So if we type that into our calculator, we will get our standard deviation. So let's type it in. So it's the square root of 8096.25 over 100, close brackets, minus the mean squared, which is 811.5 over 100, close brackets, squared, and that gives me the corresponding value of 3.89. So I'm going to round it to one decimal place, which is 3.9. So we get approximately 3.9. So if we want to check our results on a calculator, we can do that, but you still need to show the required steps in your calculation, what the sum of fx is, what the sum of fx squared is, what n is, and then you can write the formula down, substitute the values in, and you would still get full marks in the exam, because the working out still needs to be shown. So we can check that our mean is approximately 8.1 and our standard deviation is 3.9. And if we compare our results on the calculator, we can see, yes, indeed, the mean is estimated to be 8.1 and the standard deviation, sigma x, is 3.9, approximately to one decimal place. So our calculation is correct. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we've got the midpoint here. So let's get our statistics that we need. Let's get our calculator. Let's go to option 6, one variable. Let's type in the midpoints: 30, 42.5, 47.5, 55, 70. Let's write the corresponding frequencies for each value. So we've got 12, 13, 25, 32, and 8. Let's go to AC. Let's go to option, go to one variable calculation, option number 2, and then we can write down our key values. So we want the sum of fx, which is 4420. So let's write that down. So the sum of fx is going to be 4420. We need the sum of fx squared. So the sum of fx squared is 226687.5. And we also need to know what the total number of values are, the sum of f. And we get that from n, which is 90. Double check, this is 90, it's correct. So let's write sum of f is 90. Now we can proceed. So the formula for the mean is x bar is the sum of fx over the sum of f. In our case, it's going to be 4420 divided by 90. This time we're going to round it to 3 significant figures, because most mark schemes do use 3 significant figures. So let's do 4420 divided by 90, which gives me 49.1. Remember, we must use the true value in the standard deviation calculation. So let's write down the formula for standard deviation. So sigma is the square root of sum of fx squared over the sum of f minus the mean squared. So in our case, it's going to be sigma. So we're going to get 226687.5. So 226687.5 divided by the sum of f, in our case, is going to be 90. Minus the mean squared. Now be careful, do not use a rounded value. It must be the true value. So we're going to do 4420 over 90. So 4420 over 90, and then we're going to round our solution to 3 significant figures respectively. So it's the square root of 226687.5 over 90 minus 4420 over 90 all squared, and then we should get our solution, which is 10.3. So I'm going to write 10.3 for our standard deviation, and we can check our statistics with the calculator. And as we can see from the calculator, that our mean value definitely concurs with the calculator to be 49.1, and then the standard deviation they've got is approximately 10.3 as well, the 3SF. So it is mine, 10.3 to 3 significant figures. And that's how you use a calculator to work out the mean and standard deviation of group data. Please follow the same steps because those marks are awarded in the exam.